Find and allocate data to tests using AI. So you can easily find test data that matches with your tests. Once you've found it, you can reserve it, and you can accelerate the whole process using AI. It's founded on our metadata dictionary and any discovered relationship. You can use AI to construct the queries, and then we will go off and reserve it. Now, why would you want to do this? Firstly, fragmented approaches. Most teams really use different methods of finding the exact data needed to run a test. And if they're using automation, they may well include some kind of SQL at the end to validate that expected and actual results match. So using this approach, we switch to using the characteristics of the data rather than using hard-coded values. Once we've found the data, we can reserve it for exclusive use or for read-only use. It can also help you stabilize automation frameworks, as most automation bugs aren't actual bugs, they're more related to the data. And find and reserve removes test data contamination or cannibalization. So first things first, we build up a dictionary of data structures. We will document the structures, and we will also discover any hidden relationships, which is very important when you're trying to find data across multiple tables and indeed across multiple systems. So how does it work? We'll use the textual data dictionary, any discovered relationships, and any AI and LLM accelerators. Now we can then construct the query. This can be form driven, or you could enter SQL, or more commonly nowadays, you can just enter textual requests using AI. We then run the find and allocate. Once we've found the data, we will allocate keys for sole or team use. And we can also allocate for how long those keys are held. And once the time has expired, they will be released for use by other team members. So let's have a look at a little example. Here we're looking at a DB2 system with a small banking application. This is our Insights tab showing you all the activity that's been going on using the ETD product. If we look at the definition itself, these are a bunch of tables sitting in the DB2 database. We've auto-documented them, and this is useful for when we're searching for data. And we've also grouped them together, and we've also gone off and discovered relationships by scanning the data. And out of that, we've built up a pretty robust entity relationship diagram with lots of joins in there, so we can then search across the data using a combination of the joined data and the definition documentation, both on the tables and on the columns within the table. So here is our find data activity. So type find data. Now there's a couple of different forms that have been created, and this is how your user would request the data. I'll start off with one of our more traditional forms, and what we've done is we've scanned the data, found any enumerations inside the data, like so, and those then become available within the form for you to search on. And you can also then adjust it to put in various different more sophisticated types of searches, greater than or equal to, or contains, etc. So in this case, I'm going to pick up a VIP, checking I want a mail. How many do I want? 2 of them. I'm going to allocate them as well. So I'm going to say Hughes to VIP mails and fire this off. That's finished, and it's allocated a couple of accounts, 757 and 758, which I can now pick up and use. In the background, we keep track of all of these, and if we look at our reservations, we will see the accounts that have been allocated, and we have got the SQL that's been constructed from the form, like so. I can also, when making a request, reserve the data for unique use, as in no one else can use that account ID. So in this case, let's just pick up a VIP. I'm going to call it Hughes VIP, and I'm going to assign it a unique lock. And if we fire that off, it will not use any of the values that have already been allocated to read-only requests. And that's 759. And if we go and look inside, you'll see this has been assigned to as a write 759, and it hasn't picked up any of the other keys that have been allocated to other tests. Now let's look at running this using AI rather than a very structured form. So here we've created a very simple form, which basically just has one block, which allows you to enter text. So in this case, I'm just going to look for gender of M, and an account balance greater than 100 with an increasing credit score. And also I'm interested in the order and an order by account balance. So let's say this is now Hughes Mail greater than 100, increasing credit score. And how many do I want? And let's get 2 of them, and we'll fire this off. So this has made a call out to the AI engine that has then constructed the SQL and run that against the backend database looking for any joins, and then it has returned 750 and 767. And if we just take a look at the allocation list now, you can actually see in here the SQL that it has constructed, and it's actually done a pretty good job of working out that the current credit score is greater than the prior credit score, and also ordering it by the account balance. And then it has allocated 750 and 767 simply by entering text into the form to find the data that you need. So if you'd like to give it a try, feel free to get in touch.